We want to let a of x be equal to the definite integral of f of t from 0 to x with f of t graph below. We also only want to consider the graph on the closed interval from 0 to 6. So we'll be considering the graph from here to here. We're asked to find at what x values does a of x have a local maximum, and at what x values does a of x have a local minimum. So to review, if a function changes from increasing to decreasing, we have a local max. Again, when the function changes from increasing to decreasing. And when a function changes from decreasing to increasing, we have a local min. Again, when the function changes from decreasing to increasing. And since a of x is equal to this definite integral, it might be helpful to think of a of x in terms of area bounded by the function and the x-axis. So let's go ahead and shade the area bounded by the function and the x-axis on the closed interval from 0 to 6. Notice on the interval from 0 to 1, the function is above the x-axis, and therefore the definite integral would be equal to the area bounded by the function and the x-axis, or this blue shaded region, which means a of x would be positive and increasing on this interval. But then notice on the interval from 1 to 3, the function is below the x-axis or negative, and therefore the definite integral on this interval would be negative because the function values are negative. So we can think of this as being negative area, and therefore a of x would be decreasing on this interval. And then on the interval from 3 to 5, notice how the function once again is non-negative, which means on this interval, a of x would be positive and increasing to accumulate this area on this interval. So again, a of x would be positive and increasing on this interval. And then finally from 5 to 6, again, the function drops below the x-axis, or is negative, and therefore the definite integral would also be negative on this interval, and therefore a of x would be decreasing on this interval. So notice at x equals 1, a of x would change from increasing to decreasing, which means we have a local maximum at x equals 1. But then at x equals 3, a of x would change from decreasing to increasing, so we have a relative or local minimum at x equals 3. And then at x equals 5, again, a of x changes from increasing to decreasing, so we have another local maximum at x equals 5. I hope this explanation helps.